Good morning, students. Today you'll discuss about the refraction of light through a rectangular glass slab. Now you know that the change of path of light ray in the same medium is called reflection, and the change of path of light ray when passes from one medium to another medium is called refraction. So let us consider we have a rectangular glass slab PQRS, and as shown in figure, and a ray AB is incident on the face PQ at an angle of incidence I. On passing the glass slab, it bends. On passing the glass slab, it bends towards normal and travel along BC at an angle of refraction. This is I1. This is I1, and the emergent ray CD. This is we have a emergent ray CF at an angle of CD bends away from the normal at an angle of refraction. This is E. So if you applying the Snell's law or at the surface PQ, sine I upon sine R is equal to A mu G, because you know the sine R upon sine I upon sine R is equal to refractive index of the second medium with respect to first medium. So here second medium is glass and the first medium is air. So we can write A mu G. Similarly, for refraction at angle at face SR, that is sine I1 upon sine E, sine I1 upon sine E is equal to G mu A, means refractive index of air with respect to glass, because it passes from glass to air. So the second medium will be treated here as air. Multiplying this equation 1 and 2, you will find sine I upon sine E, this is E is angle of emergence, sine I upon sine E is equal to A mu G into G mu A. We know, according to the principle of reversibility of light, when a mirror is placed perpendicular to here, then after number of reflection, the light ray retraces its path. So it will go from this path to this path. It will grow from here, so it will retrace its path. So we can write G mu A is equal to 1 upon A mu G. So now it will be equal to sine I upon sine E is equal to 1, because I1 is equal to R. So we can write here. Now, so we will find here that the angle of incidence is equal to angle of emergence. So we can conclude that emergent ray CF is parallel to the incident ray. So here you will find here that if there will be no glass, you see here, if there will be no rectangular glass slab, then light could have traveled a straight way, that is in the direction of ABM. But due to the presence of the glass slab, which behaves as a denser medium, this ray is bended. This ray is bended towards the normal. So there is a bending. So this shift, that is the displacement CD, which is the perpendicular distance from the displacement CD, perpendicular distance between the direction of incident ray and the emergent ray. The perpendicular distance between the direction of incident ray, perpendicular distance between the direction of incident ray and the emergent ray. This is the direction of incident ray is AM, and refracted ray is this much, this BC. So this perpendicular distance, so we can see here this perpendicular distance CD is known as lateral displacement or lateral shift, and this will depend upon the three factors. The first factor is thickness of the glass slab, angle of the incidence, and value of the refractive index. Means if the glass slab is more thicker, then its lateral displacement will be more. If the ray of light falls with the more angle of incidence, then it will also increase, and if the refractive index of the glass will more, then the lateral displacement will be more. So this is what we observe here, that there are two refractions. first from air to glass, then from glass to air. So two refractions are taking place in case of glass slab. So we can see here, we concluded here that in this case the incident ray and the emergent ray are parallel. So thank you very much, and you'll discuss later on the next topic.